Okay, so for this part of it, we're going to do solving systems of equations. Here on the first day of February. And we're going to do it two different ways for this thing. We're going to do elimination. And sometimes with elimination, they will call this the addition or subtraction method. Most of the time, it's addition. Or substitution. Okay. And most of the time, after we go through and show you both of these, most everybody's going to say, ooh, I really like addition. Why don't we do addition method? You can, but in some cases, substitution actually is easier. And you may say, well, I don't think it is. Well, if that's the case, you don't necessarily have to do it that way. But here's the thing. If you're going into pre-cal, there are going to be times in pre-cal when you can do something with addition, and there's going to be some times where you have to do substitution, or else you make your work about 10 or 15 times harder. So, we'll show you both of those, and then when you get into pre-cal, they'll go through and do some stuff. And again, there'll be times where you'll be able to do addition or elimination method, but also there's going to be times where you're going to have to do substitution just based on the problem. So, okay, so what a system looks like is basically this. It's taking two equations. Standard form could be y equals mx plus b form, but any equations that we've got that's in some type of linear form that's here. And we're basically just putting two of those together just like we were graphing them yesterday. So yesterday we said, a system is an equation with two or more equations with two or more variables. Today, again, still basing on that same thing for this one. So here's your example. Okay, yesterday we were graphing them. We're not going to graph these today because the problem becomes when we graph these. What if the answer is negative 1/2 and 1/3? If you've got that on a graph, and if we're going back and graphing like we were doing yesterday, and you graph this line and you graph this line, how do you know exactly what that point is that's right here? You don't, do you? I mean, because we know it's about 1.5, maybe, and this is maybe 1.5, but that answer could be 1.45. For the x, it could be 1.42. It could be 1.5. It could be 1.4 repeating. It could be 1.49873. So on that one, if it doesn't hit exactly on one of the integer answers on this one, you don't know what the exact answer is. So now you can guess, if guessing is okay. But if you're looking for an exact answer, graphing a lot of times is not going to give you that exact answer that you're looking for. So that's why we're going to have to solve this thing mathematically or algebraically when we go through this stuff. So, all right, so here's the big things you're going to do. To solve by elimination. Or again, it's the addition method. You add the equations together. Therefore, that's why they call it the addition method sometimes. So you add the equations together. Here's why some people call it elimination method. So you add the equations together to eliminate one of the variables. Okay, now so for this equation, we'll actually solve this one here in a minute. We're going to add, and we'll work this out in just a second. We're going to add these two equations together because if we do that, we've got 8y minus 8y, which means this equation, the y's with variable, cancel out. And then we're left with the x's, and then we would solve this part of it. So after we find, we'll say after finding the value of the remaining variable, hang on. That's making sense here. So find the value of the remaining value. Well, no. Let's say that better. Finding the value of the remaining variable. You're going to plug that value into any original equation to find the value of the other variable. Okay, now here's the big thing that you want to do when you're eliminating these variables and moving this stuff around and doing what you want to do. The big thing that you're looking for, because sometimes we do this and people are, all right, what am I really trying to do in this case? Here's what you're really trying to do. You want the same number, same coefficient on the same variable in both equations. And there's one catch for that. So same number, same variable, both equations, where one is positive and one is negative. Okay, so if that's the big picture of what you're trying to do with elimination or addition method for this thing, is you're trying to manipulate the equations so that you've got the same number on the same variable in both equations, but one of them is positive and one of them negative. And if that's the case, then you're adding them together to eliminate one of the variables, and that's the whole big thing that we're trying to do here. So, all right. So what we're going to do, we're going to go back to this example that we had up here and show you how we would walk through that one, and then we'll just, we'll make it a little bit more difficult because this is about as easy a problem as you can get, and we'll just make it, a little bit more difficult as we go along. Okay, so we've got negative 2x plus 8y equals negative 8. 5x minus 8y equals 20. And with two equations, usually they don't do this. We'll actually do three equations tomorrow. So just for practice, we'll go ahead and put E1 and E2 here. So now this is equation 1 and this is equation 2. Okay, and again, we're trying to find out where these two lines would cross. We're looking for a point of intersection, and we're trying to figure out where's this point of intersection if we graph these two lines without graphing them. Because again, the graph might be on some decimal number somewhere that we would never know what that number would be, if we were actually looking at a graph of this thing. All right, so this is what we already have. We've got 8y and negative 8y. So we've got the same number on the y variables. One's positive, one's negative. If that's the case, we can just go through and add those two equations together. Okay, so that will cancel out. That leaves us with 3x equals 12. Okay, divide both sides by 3, we get x equals 4. Okay, now don't get so happy that you get an answer. You go, oh, hey, I got the answer. Remember, you're looking for an ordered pair answer. So after you get this 4, you got to take this value of x equals 4, pick either one of the two equations in the original back here, doesn't matter which one, and take that number and plug it back in, then we're going to solve for x. Okay, is it okay if we pick equation 1? All right, we're going to go with equation 1. Again, it doesn't matter. Just pick one of them. Pick the one. Basically, you pick the one you think would be the easiest. I mean, that's where you get your choices here. So plug 4 in there. So that's -2 times 4 plus 8y equals -8. I'll bring that over here because I'm around the room here at the bottom. So -8 plus 8y equals -8. Add 8 to both sides. Get 8y equals 0. So we get y equals 0. Okay, and there's our ordered pair that we're looking for. In this case, it was whole numbers, so we could have actually graphed that one and found it. But again, if you had to take both of those equations, rewrite them in y equals mx plus b form, go back in and graph them, do all your slope and intercept, solving this equation probably would have been just as fast if you go through that thing. Okay, so that's one where, again, everything is perfect. When you look at it, you go, oh, I got a positive and a negative here. I cancel that out. I solve for x. I've got my answer, and we go from there. So let me give you one where that it's not perfectly set up. It's close. Where we've got to do one little thing to this thing. So everybody good there? Everybody still writing that one down? Okay. All right, so for example 2, we got 3x minus 4y equals 12, and 3x plus 6y equals -8. All right, and again, you probably won't see this yet, but it does help, especially when tomorrow when we have 3 equations. This will help us out. So I'm going to go ahead and label E1, E2 for equation 1 and equation 2. Okay, so this one is almost there. We've got a 3x and a 3x, but they're both positive. So if you get it where that they're both the same signs and the same numbers, here's what you can do. You can multiply any equation by any, and I used to not say this word, but I do now, because there's always somebody who likes to be a smart aleck. Non-zero number to help with elimination. Okay, so if this one is positive 3x and this one's positive 3x, what could we take? And so basically we need this one to be a negative, right? So what we can do then is we can take this bottom equation, equation 2, and we're just going to multiply it by -1. So then we get -3x minus 6y equals +8. And the top equation, we'll just leave it just like it is. All right, now, and usually people ask, they're like, well, does it have to be the bottom one? Do we have to multiply the bottom one by a -1? No, you could just as easily multiply the top one by a -1 and leave, and just move that -1 up here and just, not multiply that one. Again, there are multiple correct ways to do these equations, so there's not a correct answer with one correct way. It's just whatever looks the best in your eyes when you're solving through these things. Okay, so now if you put it together, the x's cancel out. You're left with -10y equals 20. Divide by 10, so we got y equals -2. Okay, so we know ordered pairwise answer, that's going to be -2. So now we're going to take this -2 and we're going to plug it back into any equation we had to start with. Last time we used equation 1 just to be something different. This time we'll use equation 2. Again, it doesn't matter. Just pick one of the two and plug it back in. Just picking the equation 2 just for something different here. All right, so the -2 is going to go in there. So we got 3x minus 12 equals -8. Add our 12 to both sides. I'm going to bring that back over here. So we got 3x equals 4. So we got x equals 4/3. Question?
How come we wouldn't get the same version when we just left with the -2 and then -2?
Again, the big thing is when you're doing that one, there's no way graphing wise that you could tell me that answer would be 4/3 from a graph because it's just not possible. The only way it would be possible was if they had, a graph split up so that it was in thirds when you were graphing these. Okay, so if you've got the same numbers, again, all you gotta do is take one of the equations, multiply by negative, and here's where we'll take it up one more notch because basically we've got two more examples we've got to do. So two more examples. The next one gets a little tougher, and then the last example we'll do with elimination is like the toughest one you can do, and then every one of them will be similar to that one as far as like the tough parts of it goes. Okay, so for example 3, let's go 3x plus 2y equals 6. 6x plus 5y equals 12. Okay, so this one, we don't have the same numbers this time. Not really even close on this one. So here's what we've got to do. We've got to figure out how we can make these two numbers the same or these two numbers the same. And remember, you can multiply any or really even both equations by any non-zero number to help you do this one. So here's where you want to kind of, to make the work as short as you can, you kind of start looking at it. Are 3 and 6 multiples of each other? Yeah. So that's where you want to kind of key on because there's not an easy number you can do 2.5 if you want to. So if we were trying to get these two to match up, you can multiply this by 2.5 to make this 5, but then you've got decimals here, then you've got something over here, and then most people don't like decimals, so let's don't even worry about decimals or fractions because that's throwing things off. So if we take this top equation and multiply it by 2, now we've got 6x here. Okay. Now, the only problem with that one is if we just use 2, this would be 6x, right? Now, the bottom equation is already 6x, right? So if this one's already 6x and we're going to change this one, let's change this one so it's -6. So that way we cancel. So instead of multiplying it by 2, just make it -2. And that way you can kind of do 2 steps at one time with it. Because if we're trying to get rid of x, they're both positive, so we know we need a negative in there somewhere. And if we're going to multiply it by 2 to get this to 6, well, let's just make it -2 so that makes it just kind of 2 steps in one for that part. Okay, so then -2 times 2 is -4. And just speaking from past experience when you do these, don't rush through this. And this is, I'm speaking from my own personal experience here. I mess up on this one because I start to get in a hurry. Take your time on these because, don't get in too big a hurry because it's especially these signs, messing up on those signs back here. I'm always good about getting the first sign correct. Sometimes I'll get lazy and I'll forget to do something back here. So just take your time and don't rush through this thing because that's the easiest thing to do to mess these things up. Okay, adding these together. Those drop out. Now we've got, well, this is great. That's just y equals 0. So that's like best case scenario. Now we've got just y equals 0. We don't have to do anything. We've got our y value now. Okay, and again, just so that we can do this, and going back to one of the last questions there, we can take this y equals 0, and we can really pick any of these equations back here. So if we multiply this one by -2, we could even plug that part back in here. So we'll take this value of y equals 0, plug it back in there. The great thing about it being a 0 is that when you do -4 times 0, well, that just goes away. That becomes 0. So you're left with -6x equals -12. So that means our x value is 2. Okay, so order pair answer would be 2, 0. Okay, that seem like okay. Okay, if that one's okay, let me show you one more. This is as bad, this is as tough, this is as mean as a problem as it can get. All right, so here's the big one. Again, if you can get this one, there's nothing that you cannot get because they don't get any harder than this kind of question. Okay, so there we go. All right, now here's what makes this one hard. Are 3 and 4 multiples of each other? No. Are 2 and 3 multiples of each other? No. So we don't have anything that's multiples of each other. So if that's the case, you pretty much have to, really what you're going to want to do in that case is you're going to multiply 3 and 4 together. Now you're starting to look for common multiples. So if I start counting by 3s and 4s, the first number that these would have in common would be 12. So I'm going to rewrite these so they're both with 12 if I'm looking at the x's. Or somebody may say, well, I'd rather go with the 2s and the 3s because I can do 2 times 3 and get 6, which is fine. So this is where there's no correct way to go to start with. You can eliminate either one and either answer is fine. Now, here's the one thing I would say. If it's like this where you've got kind of a tie, well, how it's set up, that we're going to have to multiply both equations by both two numbers to get to this one. I would say pick the one that's already got a positive and a negative because then that way you don't have to change any signs. So for this one, if we multiply this one by 3 and make this -12x minus 9y equals 15, then we want this one, when we multiply the second equation here, we want it to be 12x but positive, right? Because if this one's going to be negative, then we want this one to be positive. That way, all we've got to do now is just multiply this equation by 4. Okay, so that'll make that 12x minus 8y equals -32. Okay, so really all you're doing is you're just switching these numbers. You're going to take this number and put it up here. We're going to take this 4 and put it down here. And depending on how it goes, sometimes you might have to throw in a negative number in there somewhere. It just depends on the numbers and how you set this thing up. So I would say first, worry about getting the numbers correct first. So if this is -12x, if this number is already negative, we know we'd have to multiply this one by a negative because to get a negative times a negative to make that a positive. So just kind of, manipulate the numbers a little bit so you've got the work and the numbers kind of lining up as you go through these. Okay, so we got -12, +12. That's out. That's a -17y equals -17. So we divide those two, we get a y equals 1. Okay, and again, you can pretty much go back and plug it into any one of these equations back here, the originals, or we multiply by 3 and 4. Let's just pick the smaller ones because, the numbers are only getting bigger. So let's go back and pick one of these. Anybody got one in particular? 1 or 2? 2? All right, let's go 2. So that's 3x minus 2y equals -8. We're going to plug that y equals 1 in right here. All right, so that's 3x minus 2 equals negative 8. Add 2 to both sides. That's negative 6. Divide by 3. So we get negative 2. Okay, the good thing about Math Excel, because probably the worst thing I've seen people do in the past is they get an answer and they go, okay, I'm good, I'm done. The great thing with Math Excel is it's going to give you a blank for X and Y, or it's going to give you a ordered pair and ask you to find the answer to the ordered pair. So it's going to make you find both variables. So that is the good thing about doing it with Math Excel. Okay, and again, that is as hard a problem as you can probably come up with. And the thing that makes it hard, again, is back here, is these two numbers are not going to be multiple of each other. These two numbers are not going to be multiple of each other. Okay, now let me show you just real quick on this one. You do not have to write this down. Let me just show you that if we had picked to eliminate the y's in this case, that we would have taken equation, and again, you don't have to worry about writing this down. Let me just show it to you real quick. If we take an equation 1, multiply it by 2, you take equation 2, multiply it by 3, that way we get negative 8x minus 6y equals 10. Okay, on the bottom, if you multiply it by 3, this would have been 9x minus 6y. And hopefully that's when you go, wait, I'm getting the same number with the same signs. So down here, this one needs to be positive. So that's where I need to multiply this thing through by negative. So that would make that a negative 9x, a positive 6y. And then negative times negative would make that a positive 24. Okay. So, and that's all you got to do is just make sure you got the numbers correct first. Basically, just switch these two numbers around. And after you multiply the first equation, once you get here, if it's not opposite signs, just throw a negative in there to make it so that you switch the signs and you're good to go. Okay, and then we would have negative 17x equals 34, and we get x equals negative 2. And now we've gotten the x value first instead of the y value, but that's okay because we've still got the exact same answer, and then we're good to go. Okay, so again, that's as difficult as it gets with the two variables, with the two equations, and having to multiply by two different coefficients on that part. Okay, and that's pretty much everything they can throw at you as far as elimination goes. The last one we got to do is substitution. And we don't have to go through as many options on this one because substitution is pretty much the same for most of these that we're going to do. All right, and with substitution, step 1 is basically this. You're going to solve one equation for one variable. Now, and here's what I would tell people. If step 1 isn't done for you, I would not do substitution. Because if step 1 isn't done for you, then you're pretty much set up to do elimination and substitution. So if they don't, so even in the homework, even on the test questions, I'm not going to give you one that's to me, I'm going to give you one that's substitution where it's already set up for you to do substitution. If it's set up for you to do elimination, I'm going to tell you to do elimination. So this is one where if we're doing this one in the homework, step 1 will be done for you because it should already kind of be there for this thing. Coefficient. There we go. Okay. That for these, if you were going to have to do step 1, you're looking for the variable with a coefficient of 1 or negative 1. But again, I'm going to try to pick the ones. Again, I don't always able to control Math Excel as much as I would like to. But test-wise, I will give you one where step 1 is done for you because it doesn't make sense to do substitution if step 1 isn't done for you. I mean, just speaking honestly in that case. Because if it was me, if step 1's not done, I'm not going to do it. I'm going to do elimination or substitution because it's going to be faster. Okay, so after you have x equals something or y equals something for this part, here's where the substitution part comes in. You're going to substitute. the equation from step 1 into the unused equation. Okay. Now, once you've done the substitution, here's why most people don't like doing this one, because the math gets not harder, it's just there's more math to do. Then once you plug this thing in, now you're going to have to do some distributive property. You're going to do more combining like terms. You're going to have to do more math with substitution than you are with elimination substitution. So after you've done that one, you're going to solve the system, or you're going to solve the remaining equation. Can't write that very well. You're going to solve the remaining equation with a variable that remains. Try to write a little bit better here. So we're going to be left with x equal, you're going to be left with 2 times x plus 3, plus 5x equals 17, or whatever the number is going to be. Or it's going to be all x's or all y's. And then after we've done that part of it, we're going to do like we did with the other part. We're going to use that variable, or use that value found to plug into any original to find the second variable. Okay, so the step 3 is where we basically were doing that last step here, that once we found this first equation, we found out what this y was here, we took it and plugged it back in. Step 3 is basically doing the same thing. The only problem is you have to solve for it first. So I guess technically it'd be like 4 steps. We'll just say 1, 2, 3 steps. 3 steps was good enough for Dora the Explorer. It's good enough for us. Or Special Agent Oso, or who was the other guy? Who was Dora's buddy? Diego. There we go. Yeah, Diego. Diego also had the 3 steps there. They always had 3 simple steps, right? All right, so let me show you 2 examples. They should go pretty quick, and then after we get those 2 examples, wrap this thing up and we'll be done. And again, step 1 will be done for us, because if step 1 is not done, I would not do substitution. So we're going to have 3x plus 4 equals 12, and then y equals negative 2x plus 10. Okay, now on this test, there will be some questions that I'm going to ask you to solve by substitution. If you give me the correct answer and you solved it by elimination, you'll get 1 point for the answer, and you'll get 4 points off for not solving it the correct way that I asked. Now, and again, the only purpose of this one is that there are times in pre-calc that you will have to do substitution. So we need at least to be somewhat comfortable with it. There'll be some questions on the test. I'm going to say solve by elimination. And if you solve and give me the answer that's correct, but you use substitution, same thing. You get 1 point for the answer. You're going to lose 4 points for not following directions. So you got to at least be somewhat comfortable using both of these as we go back and forth. So, all right. So, and again, this one, equation 2 is already solved for y. Okay, so we're going to replace y with negative 2x plus 10 in equation 1. And I remember doing this one time, and actually, I think I was doing this in the college algebra class at Calhoun, and some people were struggling with it. And I was like, okay, let's try this. I was like, actually write down those words for me, that you're going to replace y with negative 2, that we took this y equals 2x plus 10. I said, all right, take out the y equals and just say replace y with negative 2x plus 10. Because they were having trouble plugging in the numbers and doing the substitution. They were just they couldn't see it. So I was like, okay, circle the negative 2x plus 10. And where you've got equation 1, because I was like, okay, you okay that we're going to, this came out of equation 2, so we're going to plug it in equation 1. I was like, are you okay with that? They were like, yeah. I was like, okay. So write down equation 1, and in equation 1, you're going to take out this y, you're going to replace it with negative 2x plus 10. And for some reason, having them write down the words made it stick a little bit better. I don't know why. But making them, and I made them write out the words. I was like, write it out just like that. Replace y with negative 2x plus 10 in the other equation. And actually doing that and seeing that, it made it stick. I don't know what the catch was, but that was something that it just seemed to stick. So I've got to where I do that, where I tell people, write it down. Actually put those words on there. And now you've got to do your distributive property. You've got 4 times negative 2x for negative 8x. You've got 4 times 10 for 40. The 3x is good. And there's our 12. And now that's our equation that we're going to solve. So 3x minus 8x is negative 5x plus 40 equals 12. We're going to subtract 40. And somebody's thinking, oh, I think we did something wrong because we don't have a whole number answer. No, we're good. Sometimes you're going to get some decimal answers. So we're going to go back and divide by negative 5. Now, when we divide by negative 5, we're going to have negative 28 over negative 5. That's going to be 28 over 5. Not too easy to work with, so we're going to change that to a decimal. Just make it 5.6. Okay, now here's if there's any good news with substitution. All the hard work has been done now. The last step is usually the easy part of it, because now that we know that x equals 5.6, we're going to plug x equals 5.6 into one of these two equations. But you're always going to use this equation that already had y equals, because it's already solved for y. Once we take this 5.6 and plug it back in here, it's easy stuff on this one. So use the one that we basically go back to this first original equation we were going with here. So we got y equals negative 2x plus 10. Again, if we plug that in for x here, that you can't see because I didn't move the paper down far enough. There we go. That's negative 11.2 plus 10. So it's negative 1.2. Okay, so the trade-off on that one is the hard work is more in the beginning back here. The easy work is at the end of it, where when we did elimination, the easy work was usually the first step, and the hard work was going back and plugging it back in and working through that one. So, okay, now just show of hands, who thinks elimination is the easier one? All right, how many people think substitution is the easier one? Okay, and usually it's that way. Some people are like, I don't really care. I don't like either one of them. But most people just usually there's about a 2-to-1 odds that people kind of like the way the addition and elimination method looks. Some people kind of like the way substitution looks. So just make sure again that you're kind of comfortable going back and forth with those. All right, one more and then we're done. Okay, so worst case scenario for this one. Go ahead and give you this part. Okay, so we don't have this where we've got one of these already solved for X or Y. So for this one, we're going to show you worst case scenario, what would happen. Now, again, if this was a test question, I would not tell you to solve this one. This would be one of those where most of the test questions I'm going to say, just solve it. I don't care. Just find a way, find the answer. But there's going to be at least one question where I'm going to make you solve it by elimination, one question where I'm going to make you solve it by addition method or substitution method. So this would be a question where I'd say, okay, I don't care. Just solve it and it's fine. But if it said to solve it by substitution, we're going to take equation 1 and we're going to solve for x. Because the x has got a coefficient of 1, it's going to be really easy to solve for that when we don't do anything. We're just going to subtract 3y from both sides. There we go. So equation 1 becomes negative 3y plus 5. Or x equals negative 3y plus 5. Okay, so this came out of equation 1. We've got to replace x with negative 3y plus 5 in equation 2. So again, if this comes out of equation 1, we've got to plug this thing into equation 2. So again, we're going to do negative 2x minus 4y equals negative 8. And we're going to replace x with this thing. So we're going to circle this and plug that back in there. Okay. If you don't like doing distributor property, then substitution is not going to be a lot of fun for you, because every time you do this, you're going to have to do some distributor property. If you're okay with distributor property, then, no big deal. Okay, so now the x is gone. Now it's just all y variables that's left. And then from here, it's just being careful of your math at this point. So that's negative, that's going to be a positive 6y minus 10 minus 4y equals negative 8. Let's go ahead and get rid of that 10, move it over here. So we got the numbers on one side, we got the variables on the other. Now, once we get rid of that 10, move it over here. You've got 6y minus 4y. Just go ahead and make that 2y equals 2. So we got y equals 1. Okay, and again, the good thing with substitution, if there's any good news, is we had this x equals negative 3y plus 5 here. That's what we're going to plug it into. And y'all can't see that because I didn't scoot it down. There we go. So we're going to take y equals 1 and plug it into this x equals negative 3y plus 5, because that makes it really easy when we do that. So that's negative 3 times 1, which is just negative 3. So x equals 2. Okay, so again, substitution. All the hard work is first. The easy work is at the end of it when we get finished with it. Okay, now this part, don't write it down, but let me just show this to you, because I could just let you figure this out when y'all see the homework, but I'll only show this to you. Let me just throw a what if at you here. What if we do this equation? We'd work this thing, plug this thing out. What if we get here and we've got both variables that cancel out? What happens if we get 0 equals 20? Doesn't make any sense, right? So in that case, that would be no solution. Because these lines don't cross, that means those two graphs are parallel. And then what if we solve this thing and we get 0 equals 0? Then you get your infinite solution. So the infinite solutions, the no solutions, it's still on the table. Just realize that, after you do that, you'll get here and you'll see it that you got two numbers that make sense or two numbers that don't make sense.